chaos theory, new science of feedback system. Suppose we look at the well-known operational amplifier circuit diagram. We have a V in and V out, and V out is fed back to the input, and this is called negative feedback because whatever the V out is going to be divided by this voltage, and part of the output is used to be as a part of the input. So simple calculation, we can get the V out equals V1 V in 1 plus R RF over RG. So the gain of this amplifier is 1 plus RF over RG. So feedbacks settle into a known value. Okay. However, if we remove RG, what happens? Then minor difference between this voltage is going to swing V out because this gain is infinitely large. So what happens is the E get larger than VE, then V out drop, then E drop, then again V out go up. So it's kind of most likely oscillate, and the way it oscillate, the waveform is unknown. Okay, it depends on the internal circuit of operational amplifier. So what happened is it is almost impossible to calculate this process because very tiny amount is going to change the output, and output come back to be the input again, and only the tiny amount is going to change output again. And this kind of system, it's impossible to predict what happens scientifically. It's called chaos. Okay, the chaos is simple. In feedback system, the error accumulate too fast to determine the final settling point. Scientifically not solvable, and that's why it's got name chaos. The example of chaos, for example, like when you swing this arm of the iron and has also the swinging point here, this kind of system, when you solve the differential equation, this part affect this part and this part affect this part. So it's going to be a feedback system, and this kind of feedback system, differential equation, nonlinear differential equation, is impossible to solve. After all, the movement of this two link swinging around looks very random, and sometimes it's almost looks like a settling, but suddenly it start swinging large again. It's not predictable. Okay, flag in the wind, the flag flapping in the wind, and this flapping way you try to calculate, it's almost impossible because flag create a disturbance of air, and that air create the flags flapping. So it's almost impossible to solve this kind of problem. Many weather phenomena, the moisture causes a weather change, the weather change causes moisture change. So it's again the feedback system, and the feedback is like only tiny feedback is going to change outcome greatly, and that's the chaos system. The characteristic of chaos system is like the many it may stable for a while, but it suddenly changed significantly. A very minor change causes a big change. Okay, the famous quote is a butterfly flap in Brazil may cause a cyclone in India. Okay, so this may be possible because tiny change is gonna accumulate. It's in the in natural feedback system, it's amplified, large and large, and finally cause cyclone. So Earth may be circling the sun, but you never know, because it's this nonlinear differential equation. It looks stable, but it's slightly, orbit is slightly deviating, and this slight deviation may cause one day huge deviation and jump out of the orbit. This we don't know. This is a new science which have never researched very well. So this phenomena is looks random. It's causing randomness in the nature. Is a chaos system. This chaos system, when you apply to the some geometry, then we can get, you may have known, this fractal pattern. So it's like, okay, you give a feedback, the previous process affect next process. Suppose you have A, B, C, and O, and you go, you take the half the distance to the A, and from this distance to B you take half the distance, and from this to C you take the half the distance, and you take the half the distance to A again. You repeat many times, and this is like a historic process. This half distance depend on, you know, the first process. I mean, half distance to the B depend on half distance to the A. Half distance to C depend on half distance to the B. So each time, each process affect next process, and this kind of system is amazingly create a very regular pattern in this triangle. If you repeat, write a program, writing program like this is very easy. You can try it out. It's create a very regular pattern. So another things is like chaos system create very ordinary behavior in the nature, and that's probably amazing things about this theory. For example, the leaves of tree. Why leaves of tree all look like this? Well, nature have certainly chaos system, and chaos system, they follow chaos system and create regular those leaf pattern. In one tree, all the tree shape is same. Why? Because I never seen the tree that every branch has a different shape of tree leaves. So nature is following chaos system and creating this ordinary shape. There is the law behind it. The biological shape. Why some animals always symmetric? Most of animals symmetric. And those are stuff that our science didn't do research much about it. So looks like this chaos system. The fractal may give some light on this kind of area. The why the nature is this shape, kind of. That's the fractals. Right now, the interest in the science. Okay. I hope you enjoy this videos. Please check other videos, and if you like, click subscribe.